June 19th, 1944. The waters west of Saipan in the Philippine Sea. Vice Admiral Jisaburo Ozawa stood on the flag bridge of the carrier Taiho, watching the morning sun climb over a calm Pacific. His combined fleet represented the most powerful naval force Japan would ever assemble in a single operation. 9 aircraft carriers, 5 battleships including the mighty Yamato and Musashi, 13 cruisers, and 28 destroyers. This armada carried Japan's hopes for the decisive naval battle that would shatter American will and force a negotiated peace. Ozawa's carriers launched the first wave at 7:30 that morning. 430 aircraft, the largest carrier strike Japan had ever mounted, roared toward the American fleet detected 60 miles to the east. The Admirals' pilots, many with barely 3 months of training, climbed into skies they believed would deliver victory. What they found instead was 15 American aircraft carriers, including 8 vessels of the new Essex class, arrayed in a defensive formation so dense with anti-aircraft fire that the engagement would be nicknamed the Great Marianas Turkey Shoot. By day's end, Japan would lose 3 fleet carriers and over 600 aircraft. But the catastrophe wasn't the battle itself, it was what the battle revealed. Ozawa's intelligence officers had told him the Americans possessed perhaps 6 to 8 carriers total in the Pacific. As his surviving pilots staggered back to their carriers, they reported not 6, not 8, but 15 flattops, with more visible on the horizon. Ships that shouldn't exist. Ships that Japanese naval architects had calculated were impossible to build in the time available. The combined fleet had just collided with an industrial reality that Japanese admirals had dismissed as American propaganda, and that collision would shatter not just ships and aircraft, but the foundational assumptions upon which Japan had built its entire war strategy. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The miscalculation had begun years earlier, rooted in Japanese naval intelligence assessments that reflected not American capabilities, but Japanese limitations projected onto their enemy. In 1941, when Admiral Isoroku Yamamoto planned the Pearl Harbor attack, Japanese naval staff had carefully studied American industrial capacity. They knew the United States possessed vastly greater steel production, larger shipyards, and a population twice Japan's size. But knowing these facts and understanding their implications proved to be entirely different things. Japan's own experience building aircraft carriers provided the framework through which they interpreted American potential. The carrier Shokaku, laid down in December 1937, required 3 years and 4 months to complete. The slightly smaller Hiryu, built under emergency conditions, still took 2 years and 10 months from keel laying to commissioning. These timelines reflected Japanese industrial reality. Complex vessels like fleet carriers demanded thousands of skilled workers, precision manufacturing, specialized components, and careful assembly that couldn't be rushed without compromising quality. Japanese planners assumed American carriers would follow similar construction patterns. When American pre-war carriers like Yorktown and Enterprise required 3 to 4 years to build, this confirmed Japanese expectations. The Washington and London naval treaties, which limited carrier tonnage and numbers, had created a framework where both nations built carriers slowly, carefully, maximizing quality within treaty constraints. Even after the treaties collapsed in the late 1930s, Japanese analysts believed shipbuilding timelines remained governed by immutable industrial physics. A fleet carrier couldn't be rushed. Attempting rapid production would yield inferior vessels, structurally unsound and operationally unreliable. This assumption carried a fatal flaw. It presumed American industry operated under the same constraints that bound Japanese shipbuilding. It failed to account for the one thing that would prove decisive in the Pacific War. American mass production capacity operating on a scale Japanese analysts literally could not imagine from their perspective. Admiral Yamamoto himself understood this danger better than most of his peers. During his years as a naval attaché in Washington from 1925 to 1927, and again from 1928 to 1930, he had witnessed American industrial capacity firsthand. He visited automobile factories in Detroit, where cars rolled off assembly lines with mechanical precision. He observed steel mills in Pittsburgh, producing tonnage that dwarfed Japanese output. He traveled to shipyards where American welders worked with techniques and equipment superior to Japanese methods. In conversations with colleagues, Yamamoto expressed unease about Japan's chances in a protracted war against American industrial might. In September 1941, months before Pearl Harbor, he told Prime Minister Fumimaro Konoe a prediction that would prove chillingly accurate. "If we are ordered to do it, then I can guarantee to put up a tough fight for the first 6 months, but I have absolutely no confidence as to what would happen if it went on for 2 or 3 years. He repeated this warning in slightly different form. "For a while we'll have everything our own way, stretching out in every direction like an octopus spreading its tentacles, but it'll last for a year and a half at the most." Yet, even Yamamoto, with his direct experience of American industry, underestimated what that industry could achieve when fully mobilized for war production. He envisioned American factories slowly converting from peacetime production, American workers gradually acquiring shipbuilding skills, American logistics, methodically organizing supply chains. What he couldn't foresee was that American industry wouldn't merely convert to war production. It would revolutionize the entire concept of how warships could be built. The numbers told a story that Japanese intelligence analysts struggled to accept. In 1939, before European war began, the United States possessed 7 aircraft carriers, the aging Langley serving as a seaplane tender, Lexington, Saratoga, Ranger, Yorktown, Enterprise, and Wasp. Japan fielded 10 carriers, maintaining comfortable numerical superiority. By December 1941, when Pearl Harbor plunged America into war, the balance hadn't shifted dramatically. The United States had lost 1 carrier, Wasp torpedoed in September 1942 during the Guadalcanal campaign, but commissioned Hornet in October 1941, maintaining 7 fleet carriers. Japan still operated 10 carriers. The early Pacific War confirmed Japanese expectations. In the Coral Sea in May 1942, American carrier Lexington was sunk. A month later, at Midway, Yorktown went down. By autumn 1942, America's carrier strength had collapsed to 3 vessels: Enterprise, Saratoga, and Wasp, with Wasp lost in September. Japanese carriers Akagi, Kaga, Soryu, and Hiryu were gone from Midway, but Japan retained 6 fleet carriers, including the powerful Shokaku and Zuikaku. The attrition war seemed to be progressing as Japanese planners had anticipated. Then the numbers started defying physics, or so it appeared to Japanese intelligence officers reviewing reconnaissance reports and signals intelligence. In December 1942, a new American carrier appeared in Pacific waters, USS Essex, hull number CV-9, commissioned on December 31, 1942. Japanese analysts noted this with concern but not alarm. The Americans were replacing losses, as expected. Carrier construction took years. This vessel represented production begun before Pearl Harbor, but Essex hadn't taken years. The keel was laid in April 1941, making her construction period just 20 months. Japanese carriers of similar size required 30 to 40 months. Already, American production timelines were running faster than Japanese models predicted. Then came USS Yorktown, CV-10, commissioned in April 1943. Named for the carrier lost at Midway, this new Yorktown shared nothing with her predecessor, except the name. She was larger, faster, and carried more aircraft. Her keel had been laid in December 1941, giving a construction time of 16 months. Impossible, according to Japanese calculations. Yorktown must have been rushed to completion, Japanese analysts concluded. She would suffer mechanical problems, structural weaknesses, reduced operational effectiveness. Then Yorktown steamed into combat in the Gilbert Islands and performed flawlessly. USS Lexington, CV-16, joined the fleet in February 1943. USS Bunker Hill followed in May. USS Intrepid in August. USS Wasp, CV-18, in November. USS Hornet, CV-12, also in November 1943. 7 new Essex-class carriers commissioned in 1943 alone. Japanese intelligence officers checked and rechecked their reconnaissance reports. 7 carriers in 12 months violated every principle of naval construction that Japanese shipbuilders understood. The mathematical reality was undeniable but incomprehensible. By the end of 1943, just 2 years after Pearl Harbor, the United States had commissioned more fleet carriers than Japan had built in the previous decade. And American production wasn't slowing, it was accelerating. Japanese Naval General Staff in Tokyo received reports from multiple sources, confirming American carrier numbers, submarine sightings, aerial reconnaissance from island bases, signals intelligence tracking American carrier task force compositions. Every source told the same disturbing story. American carriers were appearing at a rate that suggested assembly line production, as if the Americans were manufacturing these complex warships the way they built automobiles. This seemed absurd. Aircraft carriers weren't trucks, they couldn't be mass-produced, yet the evidence kept accumulating. Intelligence photographs showed multiple carriers under construction simultaneously at single shipyards. Newport News Shipbuilding had 3 Essex-class hulls in various construction stages, visible in aerial reconnaissance taken in mid-1943. The Brooklyn Navy Yard, New York Navy Yard, Norfolk Navy Yard, Philadelphia Navy Yard, and Bethlehem Steel's Fall River facility all showed similar patterns. The Americans weren't just building carriers. They were building them in parallel, using techniques that allowed multiple vessels to progress simultaneously rather than sequentially. Japanese shipyards couldn't replicate this. Japanese carriers were built largely by hand, with skilled craftsmen assembling complex systems piece by piece. Each carrier represented thousands of man-hours of specialized labor. Rushing production meant pulling skilled workers from one vessel to another, creating bottlenecks rather than efficiency gains. The American approach seemed to eliminate bottlenecks entirely through some industrial methodology that Japanese observers couldn't decipher from reconnaissance photographs. Admiral Toyoda Soemu, who succeeded Yamamoto as commander-in-chief of the combined fleet after Yamamoto's death in April 1943, faced the implications of American carrier production with growing alarm. Japanese carrier strength was declining through attrition, while American strength multiplied. In the Solomon Islands campaign throughout 1942 and into 1943, Japanese carriers had been worn down through constant operations, air group losses, and damage that required lengthy repair periods. Shokaku and Zuikaku, Japan's finest fleet carriers, spent months in repair facilities. When they returned to service, their air groups had to be rebuilt with replacement pilots, whose training was increasingly abbreviated as experienced instructors died in combat. Meanwhile, American carriers seemed to multiply like a mathematics problem gone wrong. Each reconnaissance report from Japanese submarines or long-range aircraft showed more flattops than the previous report. By early 1944, Japanese intelligence estimated the Americans had deployed at least 12 Essex-class carriers to the Pacific, with more commissioning every month. 12 carriers of a single class. Japan had never built 12 carriers of any single design. The entire Japanese carrier force at its peak numbered 10 fleet carriers plus smaller vessels. The Americans had exceeded Japan's total fleet carrier production with a single class, while simultaneously losing barely any vessels to enemy action. This numerical disparity forced a recalculation of Japanese naval strategy. The original plan, refined over decades, called for a decisive fleet engagement where Japanese naval aviation and superior night-fighting capabilities would whittle down American strength as they advanced across the Pacific. By the time American forces reached Japanese-held waters in the Western Pacific, they would be weakened enough for Japanese battleships to deliver the final crushing blow in a surface engagement. This doctrine assumed rough numerical parity in carriers, or at worst a modest American advantage. It never contemplated facing 2 or 3 times as many enemy carriers as Japan could field. Yet by mid-1944, that's exactly what confronted Japanese planners. The quality of American carriers compounded the numerical problem. Early war intelligence had suggested American carriers were vulnerable. Lexington and Yorktown, both sunk in 1942, had proven susceptible to torpedo and bomb damage. Japanese naval architects, examining battle reports, concluded that American carriers lacked the robust construction of Japanese vessels. This assessment proved catastrophically wrong. The Essex-class carriers represented a substantial evolution beyond earlier American designs. They displaced 27,000 tons standard, more than Shokaku-class carriers. Their hulls incorporated lessons from early war damage, with improved compartmentalization, better damage control systems, and enhanced anti-aircraft armament. Most critically, they carried air groups of 90 to 100 aircraft, substantially more than Japanese carriers. Where Shokaku operated about 70 aircraft, an Essex-class carrier could deploy 90 F-6F Hellcat fighters, SB-2C Helldiver dive bombers, and TBM Avenger torpedo bombers. This numerical advantage in aircraft per carrier multiplied the already overwhelming advantage in carrier numbers. By the Philippine Sea battle in June 1944, American Task Force 58 could put nearly 1,000 aircraft into the sky from its 15 carriers. Japan's mobile fleet, with 9 carriers including light carriers, could muster fewer than 450 aircraft, a 2-to-1 advantage in aircraft, backed by superior pilot training, newer aircraft designs, and proximity-fuse anti-aircraft shells that Japanese pilots had never encountered. The Great Marianas Turkey Shoot wasn't just a tactical defeat. It was the moment when Japanese naval aviation encountered the full industrial weight of American carrier production and broke against it like waves against a seawall. Vice Admiral Ozawa's surviving staff officers, interrogating pilots who returned from the slaughter, heard consistent reports. Overwhelming numbers of American fighters, anti-aircraft fire so dense it seemed to form a solid wall. Carriers, stretching to the horizon in every direction. More carriers than Japanese intelligence had said existed in the entire American fleet. The pilots weren't exaggerating. Task Force 58 operated as 4 task groups, each containing 3 to 4 carriers plus supporting cruisers and destroyers. TG 58.1 included Hornet, Yorktown, Belleau Wood, and Bataan. TG 58.2 fielded Bunker Hill, Wasp, Monterey, and Cabot. TG 58.3 deployed Enterprise, Lexington, Princeton, and San Jacinto. TG 58.4 brought Essex, Langley, and Cowpens into action, 15 carriers operating as a coordinated force, their fighter directors networked through combat information centers that gave American commanders a 360-degree tactical picture from sea level to 30,000 feet. Japanese pilots, many with minimal training, flew into this defensive network and died, not because of cowardice or incompetence, but because they faced a level of coordination and firepower that overwhelmed individual skill. American proximity-fuse shells, so secret that American crews were ordered to sink in deep water rather than allow capture, detonated near aircraft without requiring direct hits. Japanese pilots couldn't evade what they couldn't see coming. The shells simply exploded when radar detected an aircraft nearby, shredding planes and pilots with shrapnel. By the battle's end, Japan had lost over 600 aircraft and 3 fleet carriers. Taiho, Ozawa's flagship, was torpedoed by American submarine USS Albacore and sank with over 1,600 crew. Shokaku, veteran of Pearl Harbor, went down to torpedoes from USS Kavala. Hio was sunk by aircraft from the carrier Belleau Wood. American losses totaled 123 aircraft, mostly to operational accidents and fuel exhaustion, not enemy action. Not a single American carrier was sunk, not one. In Tokyo, the Naval General Staff absorbed battle, reports with deepening dread. The numbers no longer made sense within any strategic framework Japanese planners understood. American carrier production had reached a level where Japan couldn't sink them fast enough to matter. Even if Japanese forces achieved favorable exchange ratios, destroying 2 or 3 American carriers for every Japanese carrier lost, American production would simply replace the losses, while Japanese losses were irreplaceable. The industrial mathematics were brutal and unforgiving. Japan's shipbuilding industry, operating at maximum capacity, could complete perhaps 2 fleet carriers per year under emergency conditions. The Americans were commissioning one Essex-class carrier approximately every 2 months. Every 60 days, another 27,000-ton flattop joined the Pacific Fleet, fully equipped, fully manned, ready for combat operations. Japanese intelligence officers calculated backwards from observed American carrier deployments, trying to understand how such production rates were possible. The answer, when they finally grasped it, revealed a chasm between American and Japanese industrial capability that no amount of tactical skill or warrior spirit could bridge. American shipyards weren't just building carriers faster than Japanese yards. They were building them using fundamentally different methods that multiplied productivity beyond anything Japanese industry could replicate. The secrets lay in mass production techniques that American industry had perfected during peacetime automobile manufacturing. Henry Ford's assembly line methods, refined over decades, had taught American engineers how to break complex products into modular components that could be manufactured in parallel, then assembled rapidly in final construction. Detroit had built millions of automobiles this way. Now those same techniques, scaled up and adapted for shipbuilding, were producing aircraft carriers. Newport News Shipbuilding, the lead yard for Essex-class construction, had revolutionized carrier production through prefabrication and modular assembly. Rather than building a carrier from keel to flight deck in sequential stages, the yard manufactured entire sections of the ship simultaneously in specialized shops. The bow section, machinery spaces, hangar deck sections, stern section, and island superstructure were all built as separate modules, then lifted into position by massive gantry cranes and welded together. This parallel production approach meant construction time depended not on how long it took to complete one section before starting the next, but on how quickly the slowest module could be finished. With proper planning, all modules reached completion at roughly the same time, ready for final assembly. Japanese shipyards, watching reconnaissance photographs of American construction, saw the physical evidence of this modular approach, but couldn't implement it themselves. Japanese industry lacked the standardization, the prefabrication facilities, the heavy lift cranes, and most critically, the industrial coordination to manufacture complex ship sections simultaneously in different locations. Japanese carriers were built where they stood, assembled piece by piece in ways that had worked for decades. Changing these methods mid-war proved impossible. The shipyard facilities couldn't be rebuilt while simultaneously trying to maintain carrier production. The workforce couldn't be retrained while under pressure to complete vessels already under construction. The supply chains couldn't be reorganized while trying to deliver components for ships at various construction stages. American industry had started the war with these capabilities already in place, refined through years of mass-producing consumer goods. Japanese industry was trying to learn assembly line shipbuilding while fighting a war that demanded immediate results. The gap widened with every passing month. By August 1944, another wave of Essex-class carriers joined the fleet. USS Franklin commissioned in January, USS Ticonderoga in May, USS Randolph in October, USS Hancock in April. Each name represented another 27,000 tons of steel, another 90 aircraft, another 4,000 trained crew members. Japanese intelligence tracked these commissioning dates with the fatalism of mathematicians watching an unsolvable equation. The Americans were now bringing a new carrier into service every 45 to 60 days. 8 Essex-class carriers had commissioned between January and November 1944 alone. 8 carriers in 11 months. Japan's entire carrier construction program for 1944 would yield 0 new fleet carriers. Unryu, laid down in August 1942, wouldn't commission until August 1944, after 24 months of construction. She would be sunk by submarine USS Redfish in December 1944, 3 months after commissioning, having achieved nothing. Her sister ships Amagi and Katsuragi wouldn't commission until 1945, too late to affect the war. Too late to do anything except absorb resources Japan no longer had. The strategic implications had become inescapable by late 1944. Japan couldn't win a carrier war against American production. She couldn't even fight it to a draw. Every month, American strength increased, while Japanese strength decreased. The Battle of the Philippine Sea had demonstrated this arithmetic with devastating clarity. The subsequent Battle of Leyte Gulf in October 1944 confirmed it. At Leyte Gulf, Japan committed essentially her entire remaining carrier force in a desperate gambit to defend the Philippines. 4 carriers, Zuikaku, Zuiho, Chitose, and Chiyoda, sortied as part of a complex multi-pronged attack plan. All 4 were sunk. Japanese naval aviation, already gutted at Philippine Sea, ceased to exist as an effective fighting force. American carriers continued operating, seemingly invincible. During the Leyte Gulf operations, dozens of Japanese aircraft, including the first organized kamikaze attacks, targeted American carriers. USS Princeton was sunk by a single bomb hit that detonated her torpedo magazine. But the other carriers absorbed multiple hits and survived. Essex, Franklin, Belleau Wood, and others took bomb and kamikaze damage that would have sunk earlier generation carriers and remained operational. Their robust construction, improved damage control, and trained damage control parties turned what should have been death blows into repairable damage. The Essex-class design philosophy emphasized survivability through redundancy. Multiple fire mains meant a single rupture didn't disable firefighting capability. Compartmentalized gasoline storage prevented the catastrophic fuel explosions that had doomed earlier carriers. Extensive watertight compartmentation limited flooding. American damage control teams, intensively trained and regularly drilled, could contain damage that would have destroyed Japanese carriers. Yet even survival wasn't the most significant factor. The most significant factor was that when an Essex-class carrier took damage and withdrew for repairs, another Essex-class carrier immediately took her place. The task force maintained constant strength because production rates exceeded attrition rates. When Franklin was hit by bombs off Japan in March 1945 and suffered catastrophic damage with over 700 crew killed, she was withdrawn for repairs. But her absence didn't weaken the task force because USS Bennington, USS Bonhomme Richard, USS Boxer, and USS Lake Champlain had all commissioned between August 1944 and June 1945, keeping the carrier count above 20 fleet carriers. Japan couldn't replace losses. America was gaining carriers despite losses. If you find this story engaging, please take a moment to tamed, subscribe and enable notifications. It helps us continue producing in-depth content like this. Japanese admirals watching this industrial juggernaut roll across the Pacific felt the psychological weight of fighting an enemy who could absorb any loss and return, and stronger. Vice Admiral Ugaki Matome, commanding the battleship force at Philippine Sea, wrote in his diary about the hopelessness of the situation. The Americans possessed such overwhelming material superiority that tactical brilliance became meaningless. You could sink their carriers, and they built more. You could shoot down their aircraft, and replacement squadrons appeared. You could kill their pilots, and new aviators took their places, often better trained than the men they replaced, because American training programs were also expanding. The Imperial Japanese Navy had entered the war with some of the finest naval aviators in the world. Men who had trained for years, who had combat experience over China, who flew aircraft with exceptional range and maneuverability. Those men were largely dead by mid-1944. Their replacements received abbreviated training because Japan lacked fuel for lengthy training flights, lacked experienced instructors to teach them properly, and lacked time because combat losses demanded immediate replacements. American aviators in 1944 trained for 18 to 24 months before reaching fleet carriers. They learned in safe conditions, with plentiful fuel, abundant aircraft, and experienced instructors who rotated back from combat specifically to teach. When these American pilots reached the fleet, they flew superior aircraft. The F-6F Hellcat possessed more powerful engines, heavier armor, better visibility, and improved firepower compared to the legendary Zero. The Zero's advantages in maneuverability and range no longer mattered when Hellcats could dive away from trouble, when American pilots fought in coordinated divisions that covered each other, and when American carriers could always be reached before fuel exhaustion, because those carriers operated in such numbers that one was always nearby. The industrial advantage manifested in every aspect of naval combat, from the ships to the aircraft to the training systems that produced crews. Japan had lost before the first shot was fired, but Japanese admirals only fully grasped this reality after witnessing Essex-class carriers arriving in unstoppable waves. The human cost of this industrial mismatch was written in the casualty lists that Japanese Naval General Staff processed throughout 1944 and into 1945. At Philippine Sea, 3 aircraft carriers lost, over 600 aircraft destroyed, most of the aircrews killed. The mobile fleet's carrier aviation capability effectively destroyed in a single day. At Leyte Gulf, 4 more carriers sunk. The last veteran carrier, Zuikaku, went down 4 months after Philippine Sea, taking with her the institutional memory of Pearl Harbor, Coral Sea, and the early victories that now seemed like ancient history. By early 1945, Japan possessed exactly 0 operational fleet carriers with functioning air groups. Several carriers sat in port, unable to sortie because there were no aircraft to fly from them, no pilots to fly those aircraft, and no fuel to power them even if aircraft and pilots had existed. The carriers Amagi, Katsuragi, Kaiyo, Ryuho, and Junyo were effectively floating barracks, too damaged or too depleted to function as combat vessels. They would end the war at anchor, achieving nothing except absorbing resources that might have been used elsewhere. Meanwhile, American carriers numbered over 20 in the Pacific alone, with more in the Atlantic and others in final construction stages or starting sea trials. The Naval General Staff could see reconnaissance photos showing Essex-class carriers at anchor at Ulithi Atoll in the Caroline Islands. American forces had captured Ulithi in September 1944 and converted it into the largest advanced naval base in the Pacific. Aerial reconnaissance revealed dozens of warships anchored in Ulithi's massive lagoon, including 10 to 12 fleet carriers at any given time. Just sitting there, more carriers in one anchorage than Japan had built in the previous decade. The psychological impact of these photographs rippled through Japanese naval command. These weren't blurry long-range shots. These were clear images showing pristine Essex-class carriers, some so new their flight decks still showed fresh paint. Ships that shouldn't exist. Ships that couldn't be built this fast according to every principle Japanese naval architects understood, sitting together in numbers that made a mockery of Japanese pre-war planning. The technical specifications of Essex-class carriers revealed why American production outpaced Japanese construction so dramatically. Each Essex measured 872 feet in length with a beam of 93 feet. The flight deck stretched 862 feet, providing ample space for aircraft operations. Standard displacement reached 27,200 tons, with full load displacement exceeding 36,000 tons. 4 Babcock and Wilcox boilers fed steam to 4 Westinghouse-geared turbines, generating 150,000 shaft horsepower, driving the ships to speeds of 33 knots. These weren't small vessels. They were massive warships requiring sophisticated engineering, complex systems integration, and thousands of tons of specialized steel. Yet, American shipyards produced them with assembly line efficiency that Japanese observers found incomprehensible. The key lay in standardization taken to extremes Japanese industry had never attempted. Every Essex-class carrier was essentially identical. The same boilers, the same turbines, the same electrical systems, the same armament, the same dimensions. This standardization meant that lessons learned building Hull CV-9 applied directly to Hull CV-10, and those lessons propagated through CV-11, CV-12, and every subsequent vessel. Workers became increasingly proficient at specific tasks because they repeated those tasks on ship after ship. Suppliers delivered components knowing exact specifications that never changed. Installation procedures were refined and documented, creating institutional knowledge that eliminated trial and error. Japanese carriers, by contrast, were often unique designs or small classes with variations. Shokaku and Zuikaku were sisters, but subsequent carriers incorporated design changes based on operational experience. Hio and Junyo were converted from passenger liner hulls, requiring entirely different construction approaches. Taiho was a one-off design with an armored flight deck. Unryu-class carriers represented an attempt at standardization, but only 3 were completed before war's end. Each different design required its own construction procedures, its own specialized components, its own learning curve. Japanese shipyards never achieved the repetitive efficiency that American yards developed through building the same design over and over. The prefabrication methods that enabled rapid Essex-class construction represented industrial capabilities Japan simply didn't possess at scale. Newport News Shipbuilding, Norfolk Navy Yard, and other American carrier construction sites utilized enormous fabrication shops where ship sections were built indoors under controlled conditions. A typical Essex bow section, weighing hundreds of tons, would be assembled completely in these shops, with all internal framing, compartmentation, piping, electrical wiring, and equipment installed before the section was moved to the building way. This shop fabrication meant workers operated in comfortable environments with proper lighting, overhead cranes for heavy lifts, and easy access to tools and materials. Quality improved because conditions were optimal. Speed increased because multiple sections progressed simultaneously in different shops. When sections reached the building way, they were essentially complete modules requiring only welding together and connection of utilities that crossed section boundaries. Japanese construction worked differently. Most fabrication occurred directly on the building way where the ship was taking shape. Workers installed frames, then welded plates to those frames, then installed internal equipment, then added the next layer of structure. This sequential process meant later work often had to accommodate earlier installations that weren't quite precise, leading to time-consuming adjustments and rework. Weather affected outdoor work. Access was difficult in confined spaces within an incomplete hull. The building way became congested with workers, materials, and equipment, all competing for limited space. American modular construction eliminated most of these problems by moving fabrication indoors and assembling completed sections rapidly outdoors. The entire philosophy differed fundamentally, and that philosophical difference manifested in construction timelines that shocked Japanese naval intelligence. Newport News Shipbuilding demonstrated the ultimate achievement of American carrier production methodology when it completed USS Bonhomme Richard, hull CV-31, from keel laying to commissioning in just 16 months during 1944. 16 months for an 872-foot warship, carrying 90 aircraft and 4,000 crew. Japanese carriers of comparable size required 30 to 40 months under peacetime conditions, 24 to 30 months under wartime emergency construction. The Americans had cut construction time by nearly half while maintaining or improving quality. The secret wasn't just prefabrication. It was the entire industrial ecosystem supporting carrier construction. American steel mills rolled specialized armor plate and structural steel to exact specifications, delivering material that required minimal additional processing. Turbine manufacturers produced standardized power plants that dropped into engine rooms designed to receive them. Electrical equipment suppliers fabricated switchboards, generators, and electrical panels to blueprints that never changed ship to ship. Anti-aircraft gun mounts arrived complete and tested, ready for installation. Radar systems, relatively primitive in 1941, had matured by 1944 into sophisticated air search and fire control systems that American factories produced in quantity. Every component supporting carrier construction benefited from mass production techniques that drove down costs, improved quality, and accelerated delivery. Japanese industry couldn't replicate this support infrastructure. Japanese steel mills struggled to deliver high-quality armor plate in necessary quantities. Turbine production was limited by shortages of precision machinery tools. Electrical components were often hand-assembled. Anti-aircraft directors were in such short supply that priority went to battleships and cruisers, leaving carriers with inadequate fire control. Radar remained relatively crude compared to American systems, and radar production never reached scales necessary to equip all vessels adequately. These cascading shortages meant that even when Japanese shipyards could theoretically build carriers faster, they couldn't because critical components weren't available. The workforce dimension added another layer to American production advantages. By 1944, American shipyards employed hundreds of thousands of workers, many of them women who had entered industrial jobs for the first time. These workers received training in welding, riveting, pipe fitting, electrical installation, and other specialized trades through programs that took civilians and converted them into skilled shipyard labor in weeks or months. The training emphasized specific tasks rather than comprehensive craftsmanship. A worker might learn to weld one particular type of joint to one particular specification and perform that single task repeatedly across multiple ships. This specialization created efficiency even with relatively inexperienced workers. Japanese shipyards relied more heavily on traditionally trained craftsmen whose skills had developed over years of apprenticeship. These workers could perform complex tasks requiring judgment and adaptation, but they couldn't be rapidly trained or easily replaced when casualties or military conscription depleted the workforce. As the war progressed, Japanese shipyard productivity declined, as experienced workers were drafted into military service or killed in air raids. American shipyard productivity increased as training programs expanded the workforce and experience accumulated through repetitive production. The Philadelphia Navy Yard demonstrated this productivity growth when it completed USS Princeton, CV-37, and USS Tarawa, CV-40, simultaneously during 1945. Two Essex-class carriers under construction at the same facility, sharing resources, competing for the same skilled workers, yet both completing on schedule because the yard's organizational systems could handle parallel production. Japanese yards rarely attempted parallel carrier construction because resource constraints made it impractical. Building two carriers simultaneously didn't double production. It created bottlenecks, where critical workers or materials were needed in two places at once. American naval architect and marine engineering represented another critical advantage that Japanese analysts underestimated until too late. The Essex-class design incorporated lessons from early war damage in ways that made the ships remarkably survivable. The hull structure utilized longitudinal framing below the waterline for improved torpedo resistance. Transverse framing above the waterline provided structural strength while allowing flexibility in compartment arrangement. This hybrid framing system gave Essex-class carriers better damage resistance than earlier American carriers while maintaining construction efficiency. The flight deck design evolved specifically to enable rapid aircraft operations. The deck itself was armored only lightly, a contrast with British carrier doctrine that favored heavily armored flight decks. American designers calculated that unarmored decks simplified repairs and allowed greater aircraft capacity. When bombs penetrated the flight deck, damage could be patched quickly with wooden planking, and aircraft operations could resume within hours. British carriers with armoured decks proved nearly impervious to bomb damage, but they carried fewer aircraft and repairs to armoured decks took days or weeks. American designers chose capacity and rapid repair over invulnerability, and this choice proved correct in the air superiority battles of the Pacific, where more aircraft mattered more than deck armour. The hangar deck arrangement demonstrated sophisticated thinking about damage control and aircraft handling. Essex-class carriers utilized an open hangar deck design with large side openings that could be sealed during combat but left open during air operations. This design provided excellent ventilation, reducing the risk of gasoline vapor explosions. It also meant bomb hits on the hangar deck vented explosively outward through the open sides rather than building pressure that could rupture the hull. Japanese carriers with closed hangar decks suffered catastrophically when bombs ignited fuel or ammunition in confined spaces. The resulting explosions had nowhere to vent, destroying ships from internal detonations that Essex-class carriers could have survived through explosive venting. Anti-aircraft armament on Essex-class carriers evolved throughout the war as American designers learned from combat experience and as production of new weapon systems reached volume. Early Essex-class carriers mounted 4 twin 5-inch 38 caliber dual-purpose gun mounts, capable of engaging both surface targets and aircraft. By mid-1944, this armament had expanded to 12 5-inch guns in twin mounts. Additionally, Essex carriers bristled with 40mm Bofors anti-aircraft guns in quadruple mounts, numbering 48 to 68 guns depending on refit status. Smaller 20mm Oerlikon cannons provided close-in defense, with 52 to 60 guns mounted around the flight deck edges and superstructure. This massed anti-aircraft battery coordinated by radar-directed fire control, created defensive firepower that Japanese aircraft couldn't penetrate without suffering catastrophic losses. The Great Marianas Turkey Shoot demonstrated this firepower conclusively. Japanese pilots approaching American task forces encountered successive layers of defense. First, radar-directed combat air patrols of Hellcat fighters intercepted attacking formations at distances of 40 to 60 miles from the carriers. Fighters shot down aircraft before they reached the fleet. Those that survived the fighter screen then faced massed anti-aircraft fire from every ship in the task force. Proximity-fused shells detonated near aircraft without requiring direct hits, shredding attackers with shrapnel. 40mm Bofors guns engaged aircraft that penetrated to medium range. 20mm cannons provided last-ditch defense against aircraft that reached point-blank range. Few Japanese aircraft survived all these defensive layers. Of the 430 aircraft launched in the first wave at Philippine Sea, American fighters and anti-aircraft fire destroyed approximately 300. The second and third waves fared even worse, with Japanese losses exceeding 75%. These weren't marginally negative, like exchange ratios. These were losses so severe that continuation meant extinction. Japanese naval aviation couldn't sustain operations against defensive networks this effective. The operational logistics supporting American carrier operations further magnified their numerical and technical advantages. Essex-class carriers operated as part of task groups that included fast battleships, cruisers, destroyers, and, critically, fleet oilers and ammunition ships that enabled sustained operations far from fixed bases. The United States Navy had developed underway replenishment to a degree of sophistication that Japanese logistics couldn't match. American carriers could refuel, rearm, and resupply at sea without returning to port, maintaining operational tempo that kept Japanese forces constantly under pressure. The logistical train supporting Pacific Fleet carriers represented an industrial achievement as significant as the carriers themselves. Fleet oilers delivered hundreds of thousands of gallons of fuel oil and aviation gasoline. Ammunition ships carried bombs, torpedoes, artillery shells, and small arms ammunition. Stores, ships provided food, spare parts, and consumables. Fast combat support ships transferred these materials at sea, while task forces maintained formation and speed, minimizing vulnerability during replenishment. Japanese carriers required return to port for major replenishment, limiting their operational range and flexibility. The mobile fleet's sortie to Philippine Sea required carefully husbanding fuel because Japanese oilers were scarce and valuable targets that couldn't be risked close to American-controlled waters. Japanese carriers operated with the knowledge that every gallon of fuel consumed was essentially irreplaceable. Every bomb dropped was gone forever. Every torpedo expended left magazines emptier. American carriers operated without such constraints. Their logistics train brought abundant supplies, and behind that train stood American industry producing more fuel, more ammunition, more spare parts than the fleet could possibly consume. This logistical abundance transformed carrier operations. American task forces could maintain combat operations indefinitely, limited only by crew fatigue rather than material shortages. Japanese forces operated in brief surges between lengthy replenishment periods ashore. By November 1944, Japanese naval strategy had collapsed into desperation. With carrier aviation destroyed, with surface fleet remnants scattered, with fuel shortages preventing major operations, Japanese commanders turned to tactics that reflected their recognition of inevitable defeat. The kamikaze program, initiated in October 1944 during the Battle of Leyte Gulf, represented the ultimate admission that Japan could no longer contest American naval power through conventional means. If Japanese pilots couldn't survive attacking American carriers anyway, better to turn their deaths into weapons by deliberately crashing into targets. The kamikaze attacks achieved some tactical successes. Carriers were damaged, sailors killed, operations disrupted temporarily, but the strategic effect was nil, because American production replaced damaged carriers faster than kamikaze attacks could damage them. USS Franklin suffered catastrophic damage from kamikaze hits in March 1945, with over 700 crew killed. It was the worst American carrier loss of the war, yet Franklin's damage didn't matter strategically, because USS Shangri-La, commissioned in September 1944, USS Lake Champlain in June 1945, USS Tarawa in December 1944, and USS Kearsarge in March 1946. The Americans were still gaining carriers, even as kamikazes damaged some. Japanese intelligence officers tracking American carrier deployments in early 1945 counted over 20 fleet carriers operational in the Pacific, plus light carriers, escort carriers, and carriers in final construction stages or sea trials. The total American carrier fleet approached 100 hulls of all types. Japan had 0 operational fleet carriers and no prospect of completing any before war's end. Admiral Yonai Mitsumasa, Navy Minister in the final year of the war, later reflected on the psychological impact of American carrier production. In post-war interviews, Yonai described the despair among naval staff officers who monitored American strength. Every intelligence report brought news of more carriers, more aircraft, more ships. The numbers became numbing. Eventually, officers stopped trying to calculate odds of success, because no calculation yielded anything except certain defeat. The war continued because surrender was unthinkable, not because anyone believed victory remained possible. The Emperor's decision to surrender in August 1945, following the atomic bombings and Soviet entry into the war, came as a relief to many naval officers who had watched Japan's inevitable defeat approaching for over a year. The carriers that had intimidated Japanese admirals into recognition of industrial helplessness continued serving long after Japan's surrender. Essex herself operated until 1969, participating in the Korean War, Vietnam War, and serving finally as a training carrier. Intrepid survived kamikaze hits, typhoons, and post-war service, eventually becoming a museum ship in New York City, where visitors can walk the same flight decks that launched strikes against Japanese forces in 1944 and 1945. Lexington, CV-16, served until 1991, the last Essex-class carrier in commission, spending her final decades as a training carrier for naval aviators. The design that Japanese naval architects thought couldn't be mass-produced lasted generations, with some Essex-class hulls serving 50 years or more. The industrial capacity that produced them in months created warships durable enough for decades of service. This longevity proved American construction quality matched or exceeded production speed. The carriers weren't hastily built compromises, they were sophisticated warships manufactured efficiently. The human stories behind American carrier production revealed the mobilization of an entire society for industrial warfare. The workers who built Essex-class carriers came from every background. Farm girls from Iowa learned to weld. Former teachers operated cranes. College students worked swing shifts between classes. Retirees returned to trades they'd left years earlier. The shipyards operated 24 hours daily, 3 shifts rotating through the same workstations, maintaining continuous production that never stopped. This workforce represented capabilities Japanese industry couldn't mobilize. Japanese society remained more traditional, with women largely excluded from heavy industrial work. Japanese workers operated under intense pressure, but without the systematic training programs that American yards provided. The result was a workforce smaller, less diverse, and less productive than American counterparts. The social transformation that enabled American carrier production proved as significant as the technical achievements. Newport News Shipbuilding employed over 30,000 workers at peak wartime production. The vast majority had never built ships before 1941. They learned on the job, supported by training programs, detailed work instructions, and specialization that allowed rapid skill development in narrow domains. A worker might spend entire shifts installing the same pipe fittings in the same locations across multiple carriers, becoming extraordinarily proficient at that single task. This division of labor, carried to extremes, created efficiency that traditional craftsmanship couldn't match. Japanese shipbuilders, trained in comprehensive skills, could adapt to unexpected problems and improvise solutions, but they couldn't match the raw speed of American specialized workers performing optimized tasks repetitively. When Newport News Shipbuilding completed Bonhomme Richard in 16 months, that achievement represented 30,000 workers, each contributing specialized labor to a coordinated whole. Japanese yards with 5 or 10,000 workers, even highly skilled ones, couldn't compete with that scale of organized human effort. The strategic deception Japanese naval intelligence suffered wasn't the result of American disinformation campaigns. It stemmed from Japanese analysts projecting their own industrial limitations onto American capabilities. When intelligence officers calculated how long carriers should take to build, they used Japanese construction timelines as reference. When they estimated production capacity, they extrapolated from Japanese shipyard capabilities. These calculations yielded predictions that American production consistently exceeded, not because Americans lied about their capabilities, but because American capabilities operated on a different scale than Japanese analysts could conceptualize. This failure of imagination represented the critical strategic mistake that underpinned Japan's decision for war. Japanese planners in 1941 calculated that American industrial potential would take years to mobilize, giving Japan a window to secure strategic resources and establish defensive perimeters. They believed American society, comfortable and democratic, would lack the will for protracted war. They assumed American industry, oriented toward consumer goods, couldn't rapidly convert to military production. Every assumption proved catastrophically wrong. American industry converted to war production faster than Japanese planners thought possible. American society demonstrated sustained commitment to total war despite casualties and sacrifices. American military power, negligible in 1941, became overwhelming by 1944. The Essex-class carrier program embodied this transformation. In 3 years, American shipyards took a new carrier design from blueprint to mass production, completing 24 hulls by war's end with more under construction. Japan, with a decade-long head start in carrier development and combat experience dating to the invasion of China in 1937, couldn't match production from a nation that had possessed barely any carriers when Pearl Harbor was attacked. The final operational deployment of Japanese carriers came in April 1945 during Operation Ten-Go, the suicide sortie of the battleship Yamato toward Okinawa. The remaining Japanese carriers stayed in port, unable to accompany Yamato because they had no aircraft, no pilots, and insufficient fuel for the one-way mission. Carriers designed for offensive power projection sat idle as the war's last dramatic naval action occurred without them. This impotence symbolized the complete collapse of Japanese naval aviation. The carriers existed physically but had ceased to matter operationally. American carrier task forces, meanwhile, operated off the Japanese home islands with impunity, launching strikes against Japanese airfields, ports, and industrial targets. Task Force 58 became Task Force 38, a redesignation reflecting Pacific Fleet reorganization. But the composition remained the same, dozens of carriers operating in coordinated task groups, their aircraft ranging across Japan largely unopposed. In July 1945, American and British carrier aircraft struck targets in the Tokyo area, demonstrating that Japanese air defenses could no longer protect even the capital. The psychological impact on Japanese leadership was profound. Admirals who had planned the Pearl Harbor attack now watched helplessly as enemy carriers operated in Japanese waters, immune to meaningful retaliation. The industrial disparity that Japanese intelligence had initially dismissed as propaganda had manifested as complete military helplessness. Japan couldn't defend herself because she lacked the carriers, aircraft, pilots, and supporting infrastructure to contest American naval aviation. That infrastructure, destroyed through attrition and never adequately replaced, couldn't be rebuilt while under continuous attack from forces Japan couldn't challenge. The final tally of Essex-class production revealed the scale of American industrial achievement. 24 Essex-class carriers commissioned during or immediately after World War II, CV-9 through CV-21, CV-31, CV-36 through CV-40, and CV-45 through CV-47. Additional hulls were cancelled after Japan's surrender, but 13 more Essex-class carriers had been laid down and were in various construction stages when the war ended. Had hostilities continued, American shipyards would have commissioned 37 or more Essex-class fleet carriers, plus numerous light carriers, escort carriers, and other naval vessels. This production represented an industrial capacity that had no parallel in human history to that point. 24 fleet carriers in approximately 3 years. Japan built 12 fleet carriers total in her entire naval history from the 1920s through 1945. The United States built twice that many carriers of a single class during the Second World War, while simultaneously producing battleships, cruisers, destroyers, submarines, landing craft, and transport ships, tankers, and all the supporting vessels required for global naval operations. The strategic implications reshaped post-war naval doctrine worldwide. Every major navy studied American carrier production to understand how such achievement had been possible. The Soviet Union, despite receiving technical information through various channels, remained skeptical until Soviet naval architects visited American shipyards and confirmed the reality. British naval planners, who had worked alongside American forces throughout the war, incorporated American production methodologies into post-war construction. Even the reconstructed Japanese Maritime Self-Defense Force, created in the 1950s, studied Essex-class carriers as examples of optimal design for mass production. For naval historians, the Essex-class program represents a case study in how industrial capacity determines naval power in modern warfare. Traditional naval theory emphasized ship quality, crew training, tactical doctrine, and operational art. The Pacific War demonstrated that industrial production capacity trumped all these factors when disparity reached sufficient magnitude. Japanese carriers were arguably better designed in some respects than American carriers. Shokaku and Zuikaku were excellent warships. Japanese naval aviators were exceptionally skilled in early war. Japanese tactical doctrine for carrier operations was sophisticated. None of it mattered because Japan built 12 carriers, and America built 24 Essex-class carriers, plus dozens more of other types. Quality became irrelevant when overwhelmed by quantity of sufficient standard. The strategic lesson echoed through Cold War planning as the United States and Soviet Union contemplated potential naval conflict. Soviet naval strategy accepted that they couldn't match American carrier numbers, so they developed alternative approaches emphasizing submarines, land-based aviation, and cruise missiles. These asymmetric strategies acknowledged American industrial advantages rather than attempting to compete directly. The memory of Japanese carriers overwhelmed by Essex-class production informed Soviet naval thinking for decades. Never try to outproduce American shipyards in a protracted conflict. The human cost of Japanese naval defeat manifested in the hundreds of thousands of sailors, aviators, and naval personnel who died serving aboard carriers that couldn't be replaced, flying aircraft that couldn't compete, fighting battles they couldn't win because American industry had already determined the outcome. The carrier Zuikaku sank in October 1944, with significant crew losses. Shokaku had gone down in June, Taiho in June. Carriers that had struck Pearl Harbor, raided the Indian Ocean, fought at Coral Sea, and other battles were gone, taking with them irreplaceable, experienced crews. The admirals who survived watched helplessly as their fleet disintegrated under pressure they couldn't counter. The industrial mathematics that Japanese admirals finally grasped in 1944 came too late to alter strategy, but early enough to inform the despair that characterized Japan's final year of war. When Vice Admiral Ozawa watched 15 American carriers at Philippine Sea, he was witnessing the physical manifestation of industrial capacity his intelligence officers had dismissed in 1941. When reconnaissance photographs showed Essex-class carriers crowding anchorages at Ulithi, Japanese naval staff confronted evidence that their entire strategic framework had been built on catastrophically wrong assumptions. The Americans hadn't just built more carriers than Japan, they had built more carriers than Japan thought physically possible to build, using methods Japan couldn't replicate, supported by industrial infrastructure Japan couldn't match, operated by a workforce Japan couldn't mobilize. The 8 Essex-class carriers that commissioned in approximately every 45 days during the height of production in 1944 represented an industrial drumbeat of inevitable defeat. Each commissioning ceremony in an American port was another nail in Japan's strategic coffin. Each carrier that joined the Pacific Fleet made Japanese defeat more certain, more rapid, more complete. By war's end, Japanese admirals understood what they should have calculated in 1941. You cannot defeat an enemy whose shipyards can produce fleet carriers faster than you can sink them. You cannot win attrition warfare against industrial capacity that replaces losses in months. You cannot overcome numerical disadvantages when those disadvantages expand every week. The Essex-class carriers proved these principles with brutal finality, and Japanese naval officers carried the lessons into post-war lives, spent contemplating how badly they had misjudged American capabilities. The surrender came in August 1945, signed aboard the battleship USS Missouri while Essex-class carriers rode at anchor nearby, silent witnesses to industrial supremacy that had buried Japanese naval power under steel, produced in quantities that defied pre-war predictions. The admirals who had laughed at American production estimates early in the war signed surrender documents surrounded by the evidence of their miscalculation. 24 Essex-class carriers commissioned during the war, more carriers being built when hostilities ended, an industrial achievement that redefined what was possible in naval warfare. The Japanese admirals who witnessed this production capacity and recognized its implications had surrendered not just militarily, but strategically, acknowledging that the war they had started based on flawed calculations about American industrial potential could only end in complete defeat. The 8 carriers every 45 days weren't just ships. They were the mathematical proof that Japan had lost before the war truly began, doomed by industrial disparity so vast that no tactical brilliance or warrior spirit could overcome it. The lesson remains embedded in naval history, studied by strategists worldwide. Industrial capacity determines modern naval power. Underestimate your adversary's production capability at existential peril, and never ever assume that mass production techniques perfected, making automobiles can't be applied to building warships when a nation with America's industrial infrastructure decides to do exactly that. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.